Bismillahirrahmanirrahim. We have seen Express.js as a view generator in last lecture. Let's go through what we have covered till now. We have covered Node.js in a crude form, in a bare programming. We have seen HTTP server, how to create an HTTP server. Then we studied filing and creating the file streams and manipulating those streams. Then we saw MongoDB database as a database server. We also used different connectors, just like MongoDB connector, that is a client connector, and also a Mongoose connector, that is an ODM, to connect to that MongoDB using a Node.js application. Then we converted our Node application into an Express.js application. Express.js was a framework and a module that sits on top of your Node module. And using that Express.js, we converted the application into a more flexible and easy to program application. In it, we used Express generator to generate the application structure. And then we in last lecture, what we have did, we have done MVC architecture. We have converted our application into an MVC architecture. Then we used view generators, just like EJS. We used Jet as a view generator, and those view generators uses the server side to create the views. But those all though the concepts of view generator is not the part of REST architecture. So today what we will see a REST architecture, its principle, and then how we can apply those REST principle in our application. And on the basis of those REST principles, we will convert our application into a REST API. Okay, so let's start. The first thing, REST. What is a REST? REST is representational state transfer architectural style. It actually helps you to create a network application using a set of constraints and principles. It means when we say a RESTful API, it means whenever we call a server to get some resource, the server will transfer client a specific representation of the resource at that specific state of time. So the rest is the style with which we can provide the information to our client using different resources. So we have five principles of REST. An application that follows REST principle is REST API. So we have five principles of REST. We will see how these principles work and what are these principles and how these principles work. The first principle is the key abstraction of information is a resource. The first principle is about resources and URIs. Any information that can be named can be a resource. So we will see in detail what can be a resource, what is a URI, how we can define the URIs, what are the best practices to define the URIs. So what is a resource? Resource is the rest is all about resources. If we say, like, we provide an image to our client, to our end user, so that image can be a resource. If we provide a set of data record to our client, then that data record can be a resource. So any information in any form, like it can be a PDF file, it can be a database row, it can be a text file, or anything else that can be provided to the user on demand, is our resource. So resources represent information and they need to be known, not worked. So resources, that means just like an image, it is a noun. So we don't call a collection of information as a resource. Like in this case, if we see example.com/photo/, so photo slash, this folder can contain multiple information. So in this case, this is a collection, not a specific resource. If we see the example below this, we can see example.com/photo/782374. This is the number of an image. So this provides a specific resource against this URI. So this URI, a unique, uniform resource identifier, provides an access to a specific resource. Anything that's important enough to be referenced as itself, that can be resource. Something that can be stored on a computer and represents as a stream of byte, it can be resource. For example, a document information about concepts, it can be a resource. A row in a DB, a user profile, can be a resource. An algorithm, result of an algorithm, if we calculate 100 prime number, or we calculate some other Fibonacci series, or etc., the output of that algorithm that can be provided to the user is a resource. So any information that can be provided with the help of our server side is a resource. We want to apply some uh, machine learning algorithm on some data set, and we want to provide a predictive information to the end user. So that predictive information to the end user is a resource. All the processing is on the server side, is on the our REST API side, but the information that will be provided to the end user is a resource. And to access that information from a client side, we need some URI. So that URI, that link to that resource, is called our uniform resource identifier. URI is an address of the resource. A resource must have at least one URI so that a client can access that resource. No URI, not a resource. If you don't have any path to that resource in our system, so that means we cannot access that information. So a URI is a must thing. That URI should be human parsable, should be understandable to end user, so that it can easily be understood. Like, if we see some example, again, x.com software release latest.r, map slash roads and specific path, and this specific path leads towards specific resource. So CS578 is a specific resource. We can provide a specific set of information against this URI, and against this, and again all these URIs. So these are all examples of URIs. Not a so good URI means, which URIs can be very trivial to understand, not a human understandable URIs. These are the examples. Even Google use such sort of URIs to search images, or search data. Like example.com question mark, these are the variables that has been passed to this URI to get some information from the server, which define the method of access, the file type that will be returned, and other information. So although this is a URI that can be used in a REST API, but this is not a good practice to use these type of URIs, or these type of information that cannot easily parsable by the end user. End user can see and look at these information, but he has to understand the different things, like what are these variables, session IDs, and item IDs. So these are not good practices to be to use as a URI. URI needs not have structure predictability, but are valuable and easier for the human clients to navigate through the application. May have multiple URIs to refer to some resource. Like, for example, if you have a software, and you have two different versions, and the latest one, you can access it using the latest.r.zip, or the last version you have released. So in both case, it's the same. The URI is pointing towards a unique resource, a single resource. So this can be possible that a single resource can have a multiple URIs, but at least there should be one URI to access that information from our system. An application is addressable if it exposes interesting aspects of its data set as a resource. If you have something that can provide a valuable information to the client, then that information is a resource. So we have addressable application exposes a URI for every piece of information it might conceive severe, more like usually infinitely many. So for example, we can define the resources we can identify the resources that these information should be provided to the end user, and against those resources we define the URIs, a set of resources, set of URLs that needs that leads towards that resource. So for example, addressability allows a one to bookmark URIs. Like for example, if you search on a Google in a normal way out, you go to the google.com, you search CSC 578 and you enter. It provides you 10, 12, 15 pages of information related to that search. So this is the way out. You can do this way. You can directly question mark the search and provide your search query. It will return you the same information as compared to this. And in the result set, if you have 20 pages, if you have 30 pages, you can go to any page at any time. So the set of URI which provides the result is defined. Like if you follow this process, or you will go directly writing in this way, you will get the same result. So this is what our URI and the resources against that URI is defined. Second principle, so the first principle is related to defining the URIs. First you defining the resources, then defining the URIs. Second principle, all interactions are context free. Each interaction contains all of the information necessary to understand the request, independent of any request that may have preceded it. So this basically principle defines that all the information that is related to our that all the information that is basically provided to the end user is independent of any context, either what we have accessed before that, or we have requested what we have requested before, or after what we will request after that. So all the context of these information will be stateless. What is if we define in term of our server what can be a statelessness, it means in simple word, if we request a resources from Google and it returns us 100 pages of search results, we can go to page 10 instead of scrolling from page 1 2 3 4 5 6. We can directly go to the page 10, and we can bookmark that information, and we can access that page 10 after 1 hour, after 20 hour. It doesn't make any difference to Google, because that the page 10 is a complete resource which is it has provided to you, and that resource can be accessed at any point of time without any context that you need to access the first page, then you have to move second or third. No, you can directly get the result from the page 10, from the page 20. So that accessibility, that information provision by the system is actually statelessness. You don't need to depend on the state of the server or state of the client, either what he has requested before this, or what will he will request after that. Every HTTP request happens in complete isolation. It has nothing to do with the request coming before it or after it. Server never relies on the information from prior request. There is no specific ordering of client request, that is page 2 may be called from before page 1. If the server restarts, a client can resend. If a server restarts, a client can resend the request and continue from it from where it left. So it is so simple that if a server restarts, it doesn't need to reconfigure to resend all the queries which he has been performing in the last session, but he can start taking the information from the point where it left. So that is so simple. Possible states of a server are also resources. Every state of the server is actually a resource, and has a unique URI against that resource. So statefulness and statelessness, we can also explain it by example. Like if we disable back button in a browser when filling a form, that needs to be filled in a specific order. Like we will fill the first information, our name information first, then we will write our qualification, and we then move towards our experience and so on. So this is a specific order in which we have to fill the form. This is actually not statelessness, it is actually a statefulness. And in rest, what we can do, we can go to education first, then we can move towards our basic information, then we can move towards our experience, and in any order we can fill our application in any order. So this is the example what I have stated before. I can call page 10 before any other request, proceeding request. Like I don't need to go to page number 1 or page number 100. I can call I can bookmark page number 10. I can send this information, send this specific URI example.com slash some long report question mark page 10 to our to my friend, and he can open and see directly the same results which I was looking at. So in REST architecture, the server is stateless. It is regardless of the situation in which I am performing the request. It is every URI has a resource, and that resource can be accessed in any order. Order doesn't matter. And it doesn't matter I am looking at this or someone else is looking at this resource. The third principle, so what we have seen till now, we have seen there is a resource. We always define the resources for our REST, for our application, and we define the URIs against those resources. And those URIs are context free. It is accessible in any order whatever we want to represent, and in whichever way the user want to access it. The third principle is representation of resources is a sequence of bytes representable into different formats and languages. So every REST API define a set of basically output mechanisms, just like the formats in which it can display the information, XML, JSON, HTML, PDF, PPT, docs, a text, or any other format you want to provide the information. So every REST API defines its layout with which it can provide you the information. Like if we take the example of Google REST API, it can you can take the information in form of JSON, and you can take the information in shape of simple text. So it's up to you, in whichever format you want to get the access from the server. So server defines its wayouts, limited wayouts. Definitely nothing is uh, infinity. You can provide any information in shape of JSONs or XML document or an HTML view. So a server defines it, and also it defines the language in which it can provide the information. Normally, if REST API is not providing any language information, that means it is providing the information in a more generic language. That can be an English, that can be French, or any other language. So to do this representation, we can define the URIs according to those representations. For example, this is the one way. We can have many ways to define these URIs. So one way is this: I'm writing English and French in the URI, part of URI. It shows me that example.com slash press release slash 2011 and 11 2011-12 dot English. That means the resource provided against this URI will be in English. So it is very easy to understand. And so on. If I will see this URI, that means end user wants to get information into a French language. Uh, in the other way, the second mechanism is this: I have single URI, but I am embedding our HTTP request with the information which he needs to get. For example, he wants to get in French, he will set the HTTP header to French. Uh, so he can get the information in French language. So in this case, we have one URI, and in the header section we will get the information in which language we will provide the result. And in this case, for every language we have a different URI to provide the information. So each one of this way has pros and cons. If we see the first one, we will see that it is easy for end user to send the request in this format, that he want to get information in English. But as a programming aspect, as a programmer aspect, it is very difficult to write so many URIs for every language. For every URI have every set of languages. In this case, for us, programming is much easier. We can define a single URI, and we can get the header information return the result accordingly. But as per the as per the end user aspect, it will be difficult for him to set the headers. He or she should have some knowledge of setting the header, in which language the result will be provided. So this is what I have explained you. Every style has a pros and cons. Too many URIs and representations, end user client has to know. So every URI style has a pros and cons. So it's up to you, whatever you want to adopt to any of these styles. So what we have seen in our third principle, we have seen that we can provide a specific set of languages, we can provide a specific set of data types that can be provided back to the users. So we have to define it clearly, that we can provide the information in JSON format, in English language, in Urdu language, or we can provide the data in zip format, or we can provide the information into PDF format. So this is the third principle. Fourth principle is related to components perform only a small set of well-defined methods on a resource. So the fourth principle is very clear. Fourth principle says that we will work on a specific set of methods. We will not allow so many methods, so many verbs on the server, so that any user can hack through or go through our system and get the information which is not provided by us, or which is not meant for that user. So we will provide a set of normally verbs, well defined verbs. What are those verbs? We have seen it in our class also. We can say the get method, the post method, put, delete. These are the four methods which we have seen. Get is to get the information from the server, post is to provide a new resource to the server, and put is to update any information into an existing resource on our server, and delete is to remove a resource from our server. These were the four methods which we have discussed in our previous classes. What are the other methods that are possible? One of them is head method. Head method provides you a meta information about a resource. Meta information, what sort of meta information? It can provide you the status, the validity of the resource, the accessibility of the resource, and the last modification of that resource. Is it a modified resource, or it has been modified when, and many other such meta information about that resource. So head is to fetch the metadata about that resource, while get is to get actually that resource. That is the basic difference between get and head. And next is our option. Option is actually to check either one method is allowed on our REST API or not. By default, in our Express generator application, whenever a client requests to a server, the first method that it calls is basically to check the options. If you send a request through post, put, or delete method, you can see in your log information that first it will call an options, which will check either your server has allowed put method, delete method, or post method on this resource. If that method is allowed on your resource, then it will proceed towards that method. Actual route will be called later. First the option will be checked. So option is the first thing that will be checked, either for the security purpose, either your REST API is allowing a put request, a delete request, or a post request. Else it will be rejected. The request will be rejected before coming towards exact route. And the last, which is normally used, is patch. So we have total 7. What is the patch? Patch actually is similar to put, but instead of updating the complete resource, uh, it only patch the information which has been changed. For example, in this example, if we see, we are sending a replace option for the age and replace option for the website. We are only patching two information instead of it write again the whole bunch of code, whole bunch of data back to the DB. Instead, it just patch the two information into that existing resource. So patch is much more basically friendly function, friendly way out, and fast updating method for us. So patch can be used, uh, put can be used. It is up to us. We can use put for our updating query, or we can use the patch instead of that. So if we go through, whenever we get information from the server, we will use the get method. Whenever we will check either this resource is okay to access or validity of the resource, we will use the head method. If we want to add some information into the resource, we will use post method. If we want to update our existing resource, we will use put or patch method. If we want to delete any information from our server, we will use delete method. And if we want to check either this REST API supports some specific method or not, we will use the option method. So these are the methods that will be used in our REST API. Normally these methods are only used. There are many of other methods, but definitely a minimal set of methods are allowed on our REST API. So move forward. This was our fourth point on which rest basic base. The fifth is the methods, the operations security. The fifth principle is related to the security of our methods, idempotent or safe methods. Let's see what are these idempotent and safe methods. uh, Actually, there are some methods which cannot change the output, the state of our server. Just like in case of get and head method. Get and head method always access the information from the server, and those information access cannot change any state of the server, any resource availability, any resource manipulation cannot be done using uh, our get and head method. So the request does not change server state. No side effect, no changing state of the server resource. Making 10 requests is same as making one or none at all. Like in shape of get, if I want to get the information of all the employees, if I request one time or I request 10 time, it has nothing to do with the server resource. It will provide the same information again and again and again. So it has no impact on the server. So head and get are our basically save methods. Then we have idempotent methods. Idempotent methods are those methods if we execute the same operation multiple times, only there will be a change. First time there will be a change, and next time there will no change. Like for example, deleting an already deleted resource is still deleted. Like for example, I want to delete Rashid from the database. If I execute this into the database, it will delete the record. If I execute it second, third and fourth time, it is already deleted, so it has no impact on the database. Same updating and record any record. If a record has been updated one time and I execute it again, so it has no impact on the server again. So if we idempotent methods are those methods if we execute it one time or multiple time, it has the same effect on the server. So what we can say, we provide the access of save methods. When correctly used, get and head requests are safe, and get, head, put, delete are idempotent. Post is neither safe nor idempotent. If we are posting one information into database, if we execute this query again, it will add a new resource and so on. So every post request has an impact on our server. So post is not a safe or idempotent method. So the use of post is very much important. To whom we are providing this facility to post some information on our server. So post method, we will carefully see where we will use post method. So we have defined safe methods, unsafe methods. We have defined our basically idempotent methods. These methods we will use accordingly, which resources, which methods are good to utilize on a server, which methods not so good to utilize on the server, and which methods should be carefully used on a server side. Why do they matter? Let a client make reliable HTTP request over an unreliable connection. If no response, then just reissue the request. For example, I requested an information from the server, and during the request, there is a connection lost. What the user will do, he will press F5. After pressing F5, the request will be resent to the server. So if a resource is already deleted, what will happen? It will have no impact on the server. It is already deleted. If I want to get some information from the server, if that information has been provided, it will be reprovided. It has no impact on the server. But if we want to add some information and during that a connection is lost, information has been provided to the database, and if we refresh that information, it will be reprovided to the database, and we have two set of same sort of information with two identical keys. So post is not as safe. So that is a scenario. So post, we don't need to overburden our post. In our traditional technologies, we use post for every type of request. Like we want to update information, we want to delete information, we use post. But in REST principle, we use post very carefully and only to the point, to the relevant person. For example, I have an employee, I have a manager, I have students in my organization. So what I will do, I will only allow post method to the highest authority, for example the relevant, most relevant person, so that he can only add some information, to add some resources to our database. So post is very much important to understand. So if we re if we go through the points again, these are the five principles. The first thing, to create a RESTful architecture, the first thing we will figure out the data sets, what information we need to provide to the end user. Then these data sets should be converted or split it into resources, the resources which we will provide to the end user. Then we will define the URIs for the resources, and after defining the URIs for the resources, we will define the subset of uniform interface, which type of on which sort of information we will provide, like JSON, XML, or language. This will be defined. And this point is related to the representation of the data. This is related to the language of the data. And then typical course of action and sunny day scenarios, that is called sunny day scenarios, and alternative course of action, that means rainy day scenarios. So we will define those scenarios. To define those scenarios, we need to know about the status codes. So what are status code? We will go through those status code in the next slide. Before that, I'm just giving you an example of URIs and its relevant resources. For example, slash users, if comes with the post request, this will be used to create a new user. If a user slash username with the get method, the action we will provide a specific user public information to that resource. So these are the URIs, and these are the actions or resources against that URI, and these are the verbs or methods that will be applied to provide the information. So every, like in this case, you can see, if nodes comes with the get request, it can only retrieve information, and if nodes get with post request, it will provide a new node to the database. So every method and URI combinedly make a new meaning, which can be a resource or which can be addition to a resource, etc. So this is an example to defining URIs and our resources. Then the status codes, that sunny day scenarios and our rainy day scenarios. There are different status code that is used to indicate the response from the server side. That can be the first part of our status code is related to uh, the specific information. For example, if any status code starts with 2, it means it is related to success, and if it starts from 3, it means it is meant for redirection, and if starts with 4, we have client side errors, and 5, it means a server side errors. If we go through quickly, like 200, it is means okay, the page found on the server, and the server has responded back with the correct information. 201 status code indicates the request has succeeded and a new resource has been created. That means you have added some resource into the database. 202 is accepted. That means nothing has been updated, but your request has been on the server side, and it will process the information. And 204, no content, same. 300 series errors, sorry, 300 series code provides you move permanently, found and not modified. These are the information which is related to the page. Either the page is available or not, or you will redirect that information to some other page. Like if a page is not found on the specific URI, it will provide on a specific on a new temporary URI. So that is the redirections. Status 400 is related to page level errors like bad request, unauthorized request, forbidden request, and you have seen 404 that is not found. So these your status code can be used if you want to provide a page level errors to the client. And if there is some server level errors, like for example your database is down, so you will not provide directly the application with the information that the database has been down. You will provide with 500. That means the server errors, internal server error, server cannot proceed with the request at the moment. So or the server is unavailable. So these are the server errors which tells the user that there is some issue on the server side, which will be updated. That can be due to overload, that can be due to maintenance purpose, or there can be a database downtime or any issue. So you will provide with the service code. These are all the rainy day scenarios. For the sunny day scenarios, we used the 200 related codes. This is your sunny day scenarios, and these are all for your rainy day scenarios if there are some issues. So still now what we have seen the basic concepts of rest principle, concepts of rest, the 5 points on which the rest architecture works. What we have not discussed: authorization, authentication. It is not a rest, because server is always stateless, so sessions are not restful. To implement uh, sessions, that means you are compromising on restful architecture. But 100% restful architecture is not practical in any case. If we take the example of Google Map API, Google Search API, or any other Bing or any other API, you will get a key to access that information. Alternatively, there is some authorization, some authentication system so 100% restful architecture is not feasible. So what we will do, we will create a REST API, and we will encapsulate that REST API into a shell. We will provide the authentication mechanism, we can provide the session information, but not on the server side, either using the client side like cookies, or we can use the database like MongoDB stores to authenticate, to manipulate that information, to contain the tokens, to contains the keys. We will use either this MongoDB server side and client side with cookies or session information or JWTs. So
need to be unrest at times. I have explained this. Login logout, we have to provide that information, else our REST API will be overburdened with some DDoS attacks or DOS attacks. So alternatively, we want some type of mechanism to maintain sessions and maintain authentication. So benefits, there are so many benefits. I have explained it very well before. It is simpler design to navigate. You don't need to worry about the client timeout. You don't need to worry about the server restarts. Easy to access, scalable, and statelessness, bookmarkable. It is very easy in shape of client access and in case of server access. In both cases it is very easy to implement, in very easy to access the information, and too much clarity to get the information. Almost all platform provide these facilities. Either you are using pythons, you are using ruby, you are using java or any other languages. There are so many frameworks. Like, just example, I'm giving some example. Rail framework for ruby on rail, it is also REST. Django in Python, it is also REST. Jersey in Java is REST. RESTless is also REST architecture styles. Netra in Ruby also, and of course the express.js that is being studying that is also a node based REST architectural framework. So these are all REST architectures. What is not in REST, but we will study it. Like, I have explained the authentication, basic authentication, we will study it, but it is not the part of REST. Same third party authentication, like if you want to authenticate your application using Facebook, Twitter, or any other site. So we will use passport to provide a third party authentication over our REST API. So we will study it also. Session information storage, how to store in database, how to store in your client side, like sessions or cookies. And the same, if we want to implement JWT, Java JSON web token, we will also implement this. So these are all not the part of REST, but we have to use it for REST, not 100% REST, but REST API. So this is what we have studied till now. So let's see an example of REST API. This is an application which we have built using Express generator. If we see, we have added few routers here: index router, user router, and employee router. If we go to, and we have mounted that employee router on the AMP platform. If we go to the employee router, what we see, there is a connection to the database MongoDB schema. We have defined the schema, we have defined the model, and after that, what we have done, we have defined a set permissions parameter middleware. In this set permission middleware, we have defined different type of access controls. We have defined every type of method in this REST API. We can define it just like post, put, if we want to define a specific type of REST API, a specific type of methods here. Same, we can define the IP addresses. If we can handle the request from any IP address, or we can provide the information to a specific IP only. So this is also possible. We can define here the IP address. Same, the header, what sort of header we will allow. We can allow the all type of headers. Same, we can define the credentials. Are we allowing credentials or not? This is the middleware we have defined. What we will do, we will use this middleware in every route. Set permission. This whenever a route will come, it will first check either we are allowing the response or not. If we are allowing this response, then it will proceed further and will see and will provide the information. For example, in this case, against get, we are providing a list of our employees. So employee dot find sort kiya, then we have provided all the information here in shape of JSON variable. In case of put, what we did, we get the information from the client, and we updated that information into our DB, and we have provided back the JSON variable. Same in case of post variable. Now we are adding new resource into our DB. We have created model, and in that we have saved that model into our DB, and we have provided back the result to the end user. Same with the delete, we deleted that resource and informed the client, and we can get the information of specific client against that slash colon name, and so on. So we define the routes, we define and provide the results into our defined layout. In this case, we are providing into JSON format. We can define others also. We can provide into simple HTML format, we can provide into other format. So the REST API is all about getting the request from the client and proceeding it with our model and providing the result back to our client. This is what we have today. In our next lecture, we will go through the REST API in detail, and we will see in the REST API. We will build our REST API from scratch, and we will implement these concepts into that REST API. Thank you very much.